Hello, how is the sound? Is it okay? Cool. So my name is Slava. I'm a software engineer at Spotify, and this talk is very creatively titled Continuous Delivery at Spotify. So I want to talk about two main things. First, I will describe a little bit of history that we had since Spotify was founded in 2006. We've grown a lot since then, and the tech has grown a lot. And also, I want to talk a little bit of how we do continuous delivery at my team, specifically. So we've set up a continuous delivery pipeline that makes us ship things as fast as possible. But I'm not going to try to recommend you any specific products, and I'm not going to try to sell you anything, because I'm sure you use Spotify already. So let's dive into history a little bit. It all started in 2006, and back in the days, it was pretty much startup culture. So I can move really fast. I maybe don't care so much about continuous delivery or anything, because we don't have any users yet, which is the most important. And this was before we had containers or anything like that. Everybody was running Debian on their workstations. And if you wanted to build a package, you maybe package it into a Debian deb package, and then if you want to run it on a server, you basically SSH to it on a physical server, and then run apt get install my service or something like that. Pretty basic, but it worked. And of course, it was a very small company, so the server you were deploying to was probably sitting behind your desk, maybe keeping your feet warm. Moving on to 2010, and this is just 4 years later, but we have a bit more users now, and things start to get more serious. We're still not as big as today. For example, we haven't launched in the US so far in 2010, so stuff is still mostly happening in Europe. We're still using Debian packages for packaging and deploying things. But we have some deployment infrastructure, because we are more people, and manually installing things just doesn't scale. We have manual machine provisioning in 2010. So what it means is basically if you need to scale up your service, you maybe write a little form and buy some more machines and install everything in them manually. And the whole process might take days at very least. But we had DevOps as well in each team. I mean, it wasn't really called DevOps back in the days. It was pretty much like people who were working on the services were also responsible for maintaining the services and the machines they were running on, and the deployment of those services as well. So we had microservices everywhere back in 2010. And for us, it happened very naturally. I don't have any war stories of splitting a large monolith or something like that. There are pretty good ones out there, but for us, the way we organized our teams meant that people were focusing on the things they were working on. And they started building microservices quite naturally. Moving on to 2014, now Spotify is like a proper global company, and the tech is starting to reflect that. We have containers everywhere to package and deploy services. And we have automatic machine provisioning in our data centers. So if your service would be running out of capacity, you would need to do some capacity planning forward. And then it's just a matter of writing a little web UI form. And then you get new VMs immediately. And everything is automatically configured with Puppet. So it's super fast and obviously automatic already. Then we also switched to GitHub Enterprise in 2014. We were a little bit late joining that party, but what they gave us is fancy post and pre-commit hooks, so we could trigger builds through GitHub, and everything was much cleaner that way. Finally, we started using something called Helios for container orchestration and deployment. And we also made it open source. In 2014, it was a bit of Wild West when it came to container orchestration and deployment. And every company was building their own container orchestration platform and open sourcing it. And Spotify was no different from that. So we built Helios, and we used it for managing our containers and deploying post-commit. We actually open sourced it on the same day when Kubernetes was announced. But now it's pretty clear who won that little race. Not that it was a race at all. Moving on, where we start to move away from Helios to something that is more an industry standard, of course, it's Kubernetes. And that brings us to 2020, today. And like I was just saying, Kubernetes is an industry standard today, so container orchestration today kind of equals Kubernetes. So we're switching from Helios to it slowly, and we've moved off on-premise data centers as well, as much as possible. Previously, we had a mix of AWS and some on-premise services, and now we moved to Google Cloud completely. And that gives us a lot of options for flexibility, obviously. Second point I had was real continuous delivery, and I wanted to describe how we do it in the team I work in. So, how many of you know what that means? Cool, quite a lot. For those of you who don't know, Spotify Connect is a service feature in the app that allows you to transfer music from one device to another device. And this is done through backend, on the contrary of maybe cast protocols or something like this. So, for example, you might transfer your music from phone to your TV or to a smart speaker or to a Chromecast and to control it. So your devices act as a remote control for other devices that display music. And I work in infrastructure team for this. To give you an idea of the challenges we have more than 240 million monthly active users. And we need to store their playing state. And that means to store what they are playing now, what they are playing next. Are they shuffling? Are they not shuffling? And we need to distribute this state properly and accurately over all of their devices. So that whatever devices are observing the playback would be seeing the accurate state of the device that is actually playing music right now. And we also have different backend services that depend on this infrastructure, like our web API and many other services as well. So we need to make sure that those services have proper data and it's accurate all the time. The reason I'm talking about it is because I want to tell you a little bit of the continuous delivery pipeline that we've set up to support this service. But I want to define some goals that we want to achieve with this continuous delivery, because continuous delivery itself is not a goal. It's you don't aim for continuous delivery. You aim to get some value out of it. So it's like a tool. And I want to define some goals that I've listed on the next slide. So of course we want to trigger deploys post-merge automatically. And we don't want to have some manual interaction there. That's pretty standard. We don't want to package up a service and then go and manually press little buttons saying I want to deploy something. That's just many extra steps that make things slower. We don't want to have staging environment for this either. Staging environments that we have had in the past were not so convenient to work with, because you always have this problem. You have to spend time to make your staging environment reflect your production environment. And then you may use it to verify builds before they go into production. But the same time might be well spent for working on tests. So you don't need a staging environment at all. And that, I think, where we started shifting focus on, at least in Spotify Connect infrastructure team. So we are focusing to make tests better, and we don't need a staging environment, therefore. And lastly, we want really quick feedback times, because we do a lot of experiments across the company. And especially in my team, we like to deploy things really fast, so we don't have to switch focus from whatever we are working on to something else whilst it's deploying. And ideally, we want a turnaround time from merge to it being in production, something between 15 and 20 minutes. And that would allow us to really focus on actual work without having to switch focus on the previous deploys. To give you an idea how that works, I'm going to show you a part of the pipeline we use. This is pretty simple and starts with post-merge, as every post-merge pipeline does. Once we merge and GitHub triggers the hook, then it triggers something in the post-merge pipeline in Jenkins. Then Jenkins will spawn off a number of different pipelines. For example, to build a container so that it's ready for testing. And then there is a number of different testing phases that, of course, we do for the services we own. We have basic unit tests. We have integration tests that use mocked upstreams. We have integration tests that use production upstreams. But then we've been experimenting a lot with a system tests layer, specifically for Spotify Connect. And I wanted to talk a little bit about that because I think it's cool. So if you imagine that you have a service A that's under test, and it has upstream dependencies, service B and service C. If you would run an integration test that would hit production versions of service B and C, then it's pretty simple. But what that doesn't test is how services that depend on service A would be affected by this new version of service A going into production. So, for example, it doesn't really check how service D would be affected by this new version of service A. And we were thinking about system tests for this. The reason, if it would be a huge problem, we would probably start thinking about contract testing, maybe, or something like that. The reason we're not doing it is because, first of all, it's not big enough of a problem. And secondly, we will have to sort of shackle all the teams into this contract testing environment, whilst we want to keep people free to iterate on whatever they are working on. So this works like this. Every service would have own integration tests anyway. And this tests just how a particular service integrates with the rest of the services in the system. So when we have a new version of service A in this example, let's call it snapshot version of service A. We will spin it up in Jenkins, and then we are ready to test it. The first thing that the system test pipeline does is it gets a test user from a test user pool. And this is another service, a test user pool service, which is responsible for owning a number of Spotify users, which are like real Spotify users, but set up specifically for testing. We can request a user from it and use it for maybe 10 minutes. And when we call a test user pool service, we get some user X, for example. And then we are ready to start running integration tests, which make calls from the perspective of user X specifically. So this would be making calls into the upstream services. And we run all the integration tests in the system test environment. So it's service A, service B, service C, service D integration tests. And if you see here, service D is actually calling the production version of service A. So what we did actually is to redirect all the traffic that service A in production receives for user X to the snapshot version of service A that is running in Jenkins. This way, the integration tests written for service D, when they call into service A, will be actually hitting the service A running in Jenkins that contains the code that we plan to deploy. And what we're actually doing here is kind of shadowing service A in production. It's not handling any production traffic for user X. All of this is being handled by Jenkins, by the new version of service A running in Jenkins. And this might be catching problems like to validate some assumptions which service D might have done about service A, which we didn't know about. And I think it's quite powerful. Moving on. We run all those tests, and we pass all those tests. So now we're ready to create a container that's ready to be deployed. And we start deploying it into Kubernetes, into a group of Canary pods, which sit in each site. So we have sites in the US, in Europe, and somewhere else. And we have a number of pods in Kubernetes for each of the services, of course. And we have special groups of those pods, which is called Canary group. When we deploy a new version of the service, this is the group of the pods which gets the new version first. And the reason we're doing it is to make sure that the new version in the Canary group is not doing worse than the production version running on the rest of the pods. But as I said, we don't want to have any manual interaction there. So we don't want to sit and compare metrics, something like this, and look at the graphs. So of course we wrote a service to automate this for us. And this is called Canary Analysis Service, and it pings us in Slack, which is pretty cool. So when we merge a new version of the service, it pings us in Slack and says, hey, I'm going to start to deploy my amazing service. And I'm going to do the analysis for maybe 10 minutes. And what it's actually doing is constantly checking the metrics for the Canary group versus the rest of the pods in production. And this might be some metrics that we defined as key metrics for a particular service. And we are verifying that Canary pods are not doing worse than non-Canary pods. If it finds some issues, it will ping us again and will say, okay, my tests for my amazing service are failing. And it will roll it back soon if it doesn't recover. And in this particular example, it said that in site 2, which might be the Europe, for example, error ratio metric increased from 0 to 2.1%. And this might be like a ratio of 500 to 200 response codes. If it doesn't recover over the next few minutes, it will ping us again and say, my checks are failing too much, I'm rolling it back, because error ratio in this site continued to increase. Hopefully, though, that doesn't happen, and we get that everything is green, all the metrics remained at 0%, and we continue to roll it out. So that brings us to the deployment stage. So once the Canary Analysis Service concluded that Canary group is doing fine, it automatically starts deploying poster canaries or to all the pods in production. And like I said, we want this to be really fast. So the Canary Analysis Service doesn't run that long, just long enough to give us some level of confidence that it doesn't break. And of course, it's already passed the tests. So the turnaround time from merging the code to being it in production is, as I said, from 15 to 20 minutes. But at the same time, the turnaround time from merging to realizing that the code you merged is broken should be much less than that. And you would have to do some manual intervention only after the Canary Analysis Service will tell you that, okay, something broken, I made everything safe, I rolled back, now you should go and look manually, whatever broke, whatever went wrong. Of course, sometimes this doesn't work. Sometimes things slip through testing, and maybe upstream breaks. Then, of course, if things break in production, it gets a little bit more serious. We have obviously constant alerts. Somebody is always on call for each of the team, for the services we own. We have detailed metrics for the services that we own. And this isn't even the last stage of the testing, because we make very heavy use of A/B testing framework. So this might be as simple as, I want to check that this small, simple refactoring is okay. What I would normally do is, I want to deploy it to the whole production group of the pods, and it will be hidden behind the flag. And the flag is initially set to 0%, for example. And I will slowly increase the percentage, constantly monitoring the metrics to see if this is the change I'm worried about or not. But of course, if there will be problems, then it gets more serious, because you are affecting real users in this case. So then, of course, when it's too late, you would probably do something to make everything safe as fast as possible. And this normally implies a rollback. And of course, you might be woken up in the middle of the night because of something, if something is really broken. Okay. So in this talk, I talked about two things: some history overview of Spotify, and also I described how we do deploys in my team. Thank you very much, and I'm super happy to answer questions. Thank you.
How many deployments a day are you doing?
It depends. I don't have a number right now. Sometimes it's 5, 10 for a service, if we are doing some active work on a feature. It really depends.
How do you handle, when you're doing the Canary deployments, multiples of those happening
Yeah, actually, should I repeat the question so everybody hears? So the question was how we handle multiple versions going into production at the same time, right?
Yeah.
So we normally try to avoid this because if it's a microservice, you can afford to wait 15 minutes before making another deploy. So we try to, as a team, we try to negotiate whatever comes first. So the question is, if I'm on call, how many calls do I get per week? For my team, it's very low. Last time I was woken up was probably half a year ago. It depends between Spotify teams, so differs a lot.
You describe yourself as an infrastructure team. The capability that you have, is this specialized in your team, or would you say that all of the teams delivering features have the same capability that you are talking about in their own teams, or are you doing this on behalf of others?
So the question is the pipeline, you mean, we use for delivering differs from other Spotify teams, right?
Yeah, I mean, is there somebody like you doing what you
Yeah.
do in every team, or are you doing this on behalf of a large group?
Yeah, good question. So we kind of responsible for a particular service, so we are focused on this service. But we have common infrastructure and common ways to do things. So lately we made it more shared, I would say. So many other teams do it similar way. And we try to make it more and more robust and similar to each other, so people know how the whole Spotify works instead of knowing how just my team works and doing things.
Yeah, I've got a similar question. So I was at a client and they were following a Spotify culture. Is the culture at Spotify still following the Conway's law with anchors and captains? Or do you still do that? You know what I'm talking about.
Yeah, so the question is the Spotify culture with captains and everything still alive? I think what you mean is more like squads.
Squads, that's it, yeah.
Yeah, that's alive. So yeah, I was calling it a team, but internally we call it a squad.
Okay, good.
In Spotify Connect, you don't have staging environment. Is that true just for your team or for all the teams in Spotify? General rule?
The question is no staging environment the rule for just our team or for the whole Spotify? I can't say for everyone, but I don't know teams who use staging environments. I'm pretty sure there are some use cases for it, but not that I'm aware of.
For the system test example with A, B, C, D, how much do you have to know the relationship between those services to run those integration tests?
The question is how much do we need to know the relations between different services to run system tests? That's a very good point. Ideally, if you want to run a real system test, of course it will eventually imply running all integration tests on Spotify. Of course we can't afford this, that just doesn't scale. So I think we are talking about under 10 services. And of course we know that it's an assumption that some border between our services and some other services can't break. Of course it can, but we assume that the risk is very low.
When you're actually making these changes or deciding on them, is there some limit as to how big a change can be, how much it can involve, the impact it can have?
Which change?
You've got lots of little changes being progressed very, very, very quickly. But if there's a lot that needs to be changed in the system, you say that has to be broken down because of some limit into small packets, or do you have different amounts of content?
So the question is how would we deploy big changes?
Yeah.
That's a good question. Of course, the common way to do it is to break changes as much as possible to smaller ones, because it has a lot of benefits. You reduce the risk, it's easier to roll back. And but I agree with your point, sometimes it's just not possible. So then you would have to go back to manual deploys, but I don't remember we ever done it. But I can imagine there might be a case where it actually needed.
One last question, and that's it.
What do you guys use to build infrastructure as code?
Puppet? Sorry, I need to repeat the question. What do we do? What do we use for infrastructure as a code? And we use Puppet.
A couple of questions. So how coupled are your pipelines with the tooling? So if tomorrow you decide to move from Jenkins, where you move to some other tooling?
For Jenkins specific, sorry, I keep forgetting to repeat the question. How up to date our pipelines are with tooling like Jenkins? We have special teams who own this, and they are updating things as it should be. Of course, I can't say that it's always up to date. It's usually up to date for security-wise, so we close all the security problems. Yeah.
Mr. Slava will be hanging out afterwards if you've got any more questions. Can provide them,
Yep.
we'll be happy to answer them. But yeah, thanks a lot again, Slava. We've got a break now.
Thank you.